is it's saying in a right triangle, there's a special ratio that exists between the acute angles, meaning not the right angles, the other two angles of the triangle, and the different sides um, that are in the triangle. And so let's say, like angle A, for example. Right? There's a special ratio between the side opposite angle A and the hypotenuse. And there's another special ratio between the side opposite angle A and the side adjacent to angle A. And so instead of always writing out, okay, well, the side opposite and the side adjacent and the hypotenuse, they created three different words that sort of imply which sides are getting paired together. And that's really all it is. They just picked intimidating words for that. And so the three words they decided to assign are sine, cosine, and tangent. And you can never have sine or cosine or tangent stand alone. It could never just be sine equals something. It has to be sine of an angle, and it has to be cosine of an angle. It has to be tangent of an angle. And so with the sine, cosine, and tangent, the sine, so here, S for sine, you should write this. The sine is going to pair the side opposite the angle over the hypotenuse. And then the cosine of an angle, so we're going to have cosine of an angle, will pair the side adjacent to that angle over the hypotenuse. And the tangent of an angle is going to pair the side opposite that angle over the side adjacent or next to the angle. Oops, I wrote tan instead of tangent. I really wrote that bad. Let me try again. Let me make the font a little thinner. There we go. So the sine of an angle pairs the side opposite that angle over the hypotenuse. The cosine of an angle pairs the side adjacent or next to the angle over the hypotenuse. And the tangent of an angle pairs the side opposite that angle over the side adjacent or next to that angle. And so way back when, the math teachers of the world came up with a little phrase to help you remember that. And that phrase is SOHCAHTOA. Everybody say, you're going to be saying it all units. SOHCAHTOA, 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 SOHCAHTOA. SOHCAHTOA. Yeah, it sounds nice. Okay, so why? Why is this word helpful? Because if you remember SOHCAHTOA, the S in so stands for sine. O and H in the so are opposite hypotenuse. The C in ka stands for cosine. The A and the H are adjacent hypotenuse. In TOA, the T in TOA stands for tangent. O and A, opposite adjacent. So if you can remember SOHCAHTOA, you'll always be able to figure out which sides each trig function pairs. All right. So now you never use trigonometry on the right angle. It's always the acute angles in the triangle that we use it on. So here, when it says sine of angle A, let's figure this out. Is sine so, ka, or toa? So sine is so. So what does that mean it wants us to do? It wants us to pair opposite over the hypotenuse. But now it really matters which angle we're referencing this all to. And how do I know which angle we're referencing this all to? Because it tells us. It says use angle A. Well, isn't this angle A right here? So now based on angle A, we have to pair the side opposite angle A. Well, the side opposite angle A is always across. It's always the furthest one from A. So do we agree that across from angle A is that lowercase a right here? So the opposite is the lowercase a over the hypotenuse. How do we identify the hypotenuse? What is it always across from? The right angle. So what is represented by that hypotenuse? C, right? So this is going to be A over C. Now, when we do it, we're going to use real numbers. When we're actually using problems, we'll use real numbers.
Like the opposite is like the
Mm-hmm. Because H in so stands for the hypotenuse, and C is on the hypotenuse. Okay, so now they want us to find the cosine of angle A. Well, is cosine so, ka, or toa? Ka. So then we're going to use the ka. And the C and the ka is the cosine. What are the A and the H in the ka? Adjacent and the hypotenuse. You got it. So now the adjacent one is always a little tricky. So we're still referencing everything to angle A. Adjacent means next to, by definition. You're like side by side if you're adjacent. So we're looking at the side that's next to angle A. Well, aren't there two sides that are sort of considered next to angle A? You have the C and you have the B here. They're both next to. But one of them will always be the hypotenuse and the other one won't be the hypotenuse. So isn't C the hypotenuse? So that means the only one that could be adjacent to it is, and not be the hypotenuse, is B. So B is the one adjacent to angle A. So B over the hypotenuse, well, what did we say the hypotenuse was? C. I know this is different, but the more problems we do, the better it will get. And then you'll be like, oh, this is a little fun. All right, so now let's talk about tangent. Which one is tangent? So, ka, or toa? Toa. So now we're going to use toa. What is the O in toa? Opposite, good. What is the A in toa? Adjacent. And now which angle are we doing this in reference to? A. Does that matter which angle? Yeah, it matters because it changes depending on the angle. So now which side is opposite A? Lowercase a, right? And which side is adjacent to A but is not the hypotenuse? B. So it would be A over B.
So like adjacent like
Mm-hmm. All right, we ready to do real problems now? Let's do real problems. Okay, so I will tell you guys though, last chapter, the triples, the Pythagorean theorem, the 30, 60, 90, the 45, 45, 90 aren't going away. It's all showing up in this chapter also. So just so you don't put in like short-term memory, keep it up front, keep it long-term. All right, so here it says find the three trig ratios for angle A. Well, I'm looking at this triangle and there's one side missing and I need all the sides to find the three trig ratios. But this ends up being a triple. This is a 3, 4, 5. So I need to label that last side with 5. And when it says find the three trig ratios, what they're asking me for is the sine, the cosine, and the tangent. But now this time, everything is in reference to which angle? A. How do I know that they want me to use angle A? Because it says for angle A. So what does that mean? That means I need the sine of angle A. Oh, also guys, just so you know, to shortcut sine, it's just SIN. To shortcut right sine is just SIN. So I need the sine of angle A. I need the cosine of angle A. To shortcut cosine, it's COS. And I need the tangent of angle A. To shortcut tangent, it's just TAN. Now, I will tell you this. If you're ever writing sine, cosine, and tangent without an angle immediately next to it, it means nothing. It is completely wrong. Because when it says sine is opposite and hypotenuse, well, opposite and hypotenuse of what? You have to tell them of angle A. So you can't just have sine by itself, opposite and hypotenuse. Opposite and hypotenuse of what? You need an angle with it. All right, so now since everything is in reference to angle A, I'm going to label my triangle. Which number is opposite angle A? Which side is opposite angle A? 3. It's a cross, right? Further away. Which side is the hypotenuse? Jack, you know? Well, angle C is the right angle, but which side is the hypotenuse? 5. You got it. And then by process of elimination, what does that mean the adjacent has to be? 4. So that's the A. Okay, what's that special word I said that helps us remember? The special word that this whole chapter is based on. So katoa. So I'm going to write that down. So katoa. All right. So sine, we want to first answer sine angle A. Is sine so, ka, or toa? So how do you know sine is so and not ka or toa? How do you know sine is so? Because the S in so, exactly, because the S in so. So since sine is so, it means O and H. Well, based on what we labeled, which side is O? 3. And which side is H? 5. So the sine of angle A is 3 over 5. So the ratio of the opposite and the hypotenuse of angle A is 3 over 5. What's the cosine of angle A? Is it going to be so, ka, or toa? Ka. What does the A in ka represent? Adjacent. What does the H in ka represent? Hypotenuse. So we labeled the adjacent as 4 and the hypotenuse as 5. Now the tangent of angle A. Tangent is that so, ka, or toa? Toa. So that means we're going to pair O and A. Well, O is 3 and A is 4. I want you guys right now to try number 2, but be very careful. It's not going to be the same as number 1. Why? Because I'm not saying angle A anymore. What am I saying this time? Angle B, which changes things. Angle B. So everything's based off of angle B. Is this still a 3, 4, 5? Yeah. And now you're going to see when you change the angle, the ratios change. That's why it's always so important that there's an angle with each of the trig functions. Okay. What was that special word? SOHCAHTOA. SOHCAHTOA. Now everything's in reference to angle B. So can somebody tell me which side is now opposite angle B? What'd you say, Jack? 4, good. Which side is the hypotenuse? 5. And what does that mean for adjacent? 3. So now the sine of angle B is going to be so. So that is going to be the opposite, which is 4, over the hypotenuse, which is 5. The cosine of angle B is ka. So that's going to be the adjacent 3 over the hypotenuse 5. And the tangent of angle B is going to be toa, which is the opposite, which is 4, over the adjacent, which is 3. How many people got those all correct? Excellent. All right, let's keep going. We're only going to do one of these. Let's do number, I guess it doesn't matter. Let's do number 3. Find the 3 trig ratios for angle A. So what does that mean? Everything is in reference to angle A. Does it matter which angle we're using? Absolutely, it matters. So everything's in reference to angle A. This is actually a triple. Does anybody know something 8, 10? What's that missing side? 6. So I'm going to label my triangle based on angle A. Noah, which side is opposite angle A? 8, good. Jonah, which side is the hypotenuse? 10. Maya, which side's adjacent? 6. Bella, what's that special word? The word that helps us with every problem. SOHCAHTOA. Sebastian, when I go to set this up and I have to write out the sign, am I allowed to just write sine equals and write the answer here? No. What's missing? The angle. Which angle are we talking about? No. So go back and read the directions. What does it say? It says find the 3 trig ratios for angle. No, what does it? Read the directions. Find the 3 trig ratios for what? Are you looking at number 3? Yeah. For angle A, so what does that mean? Sine, not just sine by itself. It can't be by itself. It's sine what? Angle A. It always has to be with an angle. It always has to be with an angle. Jay, am I allowed to just write cos equals and write my answer? No, what does it have to be? The angle. Jack M, not Jack M, Jack C. Am I allowed to just write tangent, tan equals and write my answer? No, what do I have to do? Yep, tan and then name the angle that we're using. Okay, so now we're going to go to sine angle A. Leilani, what is the sine of angle A? You got it. But guys, because it's written as a ratio, which is a fraction, what do we always have to do to fractions? Reduce them, right? So I'm not allowed to leave it as 8 over 10. What do I have to do? Simplify. So that becomes 4 over 5 because I divided top and bottom by 2. Jack M, what's the cosine of angle A? Which simplifies down to? Jay, what's the tangent of angle A? Which simplifies down to? 4 over 3, perfect. We get it? Okay, we're gonna skip number 4. Let's keep going. We're gonna skip number 5. Let's go on to number 6. Now this one's a little bit sneaky. So it says find the 3 trig ratios for angle A. The problem is, do I have any sides even labeled? like with numbers, like it's not like 3, 4, 5, or 6, 8, 10. Nothing's labeled. But we do have to remember, I marked here that two sides are congruent. And we learned way back when, if we have a triangle with two sides congruent, what else? The base angles. The Leilani, was that you? The base, Bella? The base angles are congruent. So what does that mean? If these two angles have to be congruent and there's already a 90-degree angle in there, doesn't a triangle have to add up to 180? So that means this has to be 45 and 45. So remember I said chapter 9 was coming back into play? Now we have to remember the formula for a 45, 45, 90. Who remembers the formula for the 45, 45, 90? Jonah? You got it. Okay, so find the three trig ratios for angle A. So now everything's going to be based on angle A. So based on angle A, BC side is opposite. X root 2 is the hypotenuse, which means the other x is the adjacent. Is everybody okay with how I labeled things? Labeled the O, the H, and the A? Okay, so now we're going back to our SOHCAHTOA. So I want to find all three of them. Sebastian, could I just write sine equals and write my answer? No, what do I have to write? Sine angle A equals. Now sine is so I need the opposite, which is x, over the hypotenuse, which is x root 2. I'll let you write that and then stay with me. I am allowed to cancel out these x's because it's an x on the top, x on the bottom. I can cancel them out. So what does that mean? That means I'm going to have 1, because x divided by x is 1 over root 2. But think back to chapter 9. Am I allowed to leave a radical in the denominator? No. Who remembers what's that called? It starts with an R when I have to get the radical out of the denominator. Good, rationalizing. So when I rationalize, I'm going to multiply top and bottom by root 2. So I'm going to get that the sine of angle A is root 2 over, what's root 2 times root 2? Whole number 2. So that's the sine of angle A. Now what do I need to find? Because I said find all three. I just found sine. What should I find next? Cos. So we're going to say cos angle A. Well, that's ka. So that's the adjacent, which is x, over the hypotenuse, which is x root 2. Didn't I just do x over x root 2? Didn't I just do that for sine? And didn't I find that answer for that? So can I just use that same answer instead of doing it all over again? So this is going to be root 2 over 2 also. And that makes sense because two of the sides are the same, right? In a 45, 45, 90 triangle. So it would make sense that sine and cosine are the same because the two sides are the same, opposite and adjacent. And then lastly, we have the tangent of angle A. Jack C, tell me, what is the tangent of angle A going to be?
Be like both of the sides, right?
Yeah.
Both like x and x.
Yep, x over x. And what's x divided by x? Any number divided by itself is 1. So the tangent of angle A is 1. Yes. Yep. Let's keep going. Okay, it says find sine, cosine, and tangent of a 30-degree angle. So I need to go to my triangle and I need to label this 30-degree angle, which means it's what kind of triangle? If I have a 90 and a 30, the last angle has to be 60. Who remembers the 30, 60, 90 formula? Jack? Yep. Perfect. Yeah. So what's that special word? SOHCAHTOA. So Noah, they want us to find the sine, cosine, and tangent. If I'm going to find the sine, what should I write? So what's the sine going to be of the 30-degree angle? Say it one more time. Why? What is the sine pair? I don't believe you don't remember. Is sine so, ka, or toa? So what are those two letters? Look at it. So what are the two letters? What are the three letters in so? Yeah, S-O-H. What is the S? The S is the sine. What is the O? What's the H? You know, Noah, you just don't want to tell me. Can I ever write sine by itself? No, I have to write the angle. So this is going to be sine 30 degrees is equal. So now which side, Noah, is opposite the 30? Yep. And what side is the hypotenuse? 2x. We can cancel out those x's. So we end up with the sine of 30 is equal to 1 over 2. Who thinks they're brave enough for the cosine of 30? Who wants this one? Who wants the cosine of 30? Okay, Jay, you don't have to beg me. You could have it. Cosine of 30. All right, Jay, cosine, is it so, ka, or toa? What happened? Your throat hurts? Oh, okay. Jonah, you're up. All right, is it so, ka, or toa? Ka. All right, so the three letters in ka are C, A, H. The C is for the cosine. What are the A and the H, Jonah? Good, the adjacent and the hypotenuse. Which side is adjacent to 30? You got it, the x root 3. And what is the hypotenuse? Perfect. Guys, can I cancel out these x's? Yep, we sure can. So what does that mean? Cosine 30 is root 3 over 2. Is it okay to have a radical in the numerator? Yes, it's not okay to have it in the denominator. All right, now a little bit different here. So now we really got to use the SOHCAHTOA. So it's saying the tangent of angle M. So everything's based on angle M. So they're saying the tangent of angle M, basing it all on angle M, is 7 over 24. So we have, I'm going to rewrite it. Tan angle M equals 7 over 24. So now, what's that special word again? SOHCAHTOA. And now I have to think, is tangent so, ka, or toa? Toa. And so the toa tells us we put the opposite in the numerator and we put the adjacent in the denominator. Do we agree? That's what toa tells us. Put opposite in the numerator, adjacent in the denominator. So now we can go and label our triangle. So everything's based on angle M. So the side opposite angle M should be 7. The side opposite angle M we should label as 7. And the side adjacent to angle M should be labeled with 24. So this actually ends up being a triple. What's the triple? 7, 24, 25. So now that we filled in the triangle, now we could do the next part of the problem. What's the next part of the problem? It says find the cosine of angle M. Well, which one's cosine? So, ka, or toa? Ka. All right, so Jack M, if I'm finding the cosine of angle M, we said it was ka. So we want the adjacent to M. Which number is adjacent to M? Yep, over the hypotenuse, which is? You got it. So this is our answer. All right, let's keep going. Number 9, find each missing angle. So I'm going to look at the triangle first, and I'm going to notice it's another triple. 9, 40, what? 41. And now they're saying, find out which angle we're talking about. So they're saying the tangent of some angle is 9 over 40. Well, I'm going to go back to my SOHCAHTOA. And they're saying tangent, so I'm going to go with TOA. So they're saying the tangent of some angle gives us 9 as the opposite side and 40 as the adjacent side. So now we're going to look, and I'm going to look at the 9. 9 is opposite which angle? 9 is opposite which angle? A. And then I'm going to double check. Since 9 is opposite A, I need 40 to be adjacent to A. Well, is 40 adjacent to A as well? Yeah, so that means they're talking about angle A in this problem. So that's all we put is tangent of angle A ends up being 9 over 40. Okay, so now for the next problem, they're saying the cosine of some angle is 40 over 41. Well, cosine is ka, which means the 40 needs to be adjacent and the 41 needs to be the hypotenuse. So I'm going to go to the 40 and I'm going to ask, okay, well, the 40 is now adjacent to which angle? A again. And then I double check, is 41 still the hypotenuse? Yeah, so then again, they're talking about angle A. I want you guys to do letter C by yourself. It's never the right angle. So your option could never be the right angle as an answer. All right, what'd you guys get for letter C? 40 over 41 is the sine of which angle? B. Anybody need to see me do that? All right, moving right along. Almost there. Okay, label the sides of the triangle if the sine of angle A, so what are they referencing this all to? Angle A. So the sine of angle A is 1 over the square root of 2. So I go back to that special word, SOHCAHTOA. And I know they're saying sine, so that means opposite over hypotenuse. So now when I go to label this triangle, I have to label the one on the side that's opposite angle A. Which side is opposite angle A that I should put the 1 on? BC. And then the hypotenuse, I have to label with the square root of 2. Well, don't we agree that AB is the hypotenuse, so that's the square root of 2? Now, we need to find the missing side. You can use the Pythagorean theorem to find the missing side, but what I would really, this is a very advanced level of thinking, but I would need you to understand, you're going to need to understand it in pre-calc. Do you guys remember In a 30, 60, 90, it was x root 3, and a 2x. And in a 45, 45, 90, it was x root 2. If you have a right triangle and two of the three sides fit the pattern, it ends up being that type of triangle. What do I mean? Let's say I had a triangle and I had 6 on one side and I had a 12 on the other side. What does that mean? It means 12 is double 6, right? So this is an x and this is a 2x. If two of the three sides fit the formula, then it ends up completely being that formula, which means this has to be a 30, 60, 90 triangle. So this would have to be 6 root 3. So do you guys know what I mean when I say if two out of the three sides fit the formula? So now if you look over here, if this triangle we have, if this is x, then this is x root 2 because there's really an invisible 1 there, right? So this fits another formula. What's the formula it fits? 45, 45, 90, which means this other side has to be x, which is 1. All right, now let's do letter B. It says the cosine of angle A, so it's now all in reference to angle A, is 8 over 10. Well, cosine is ka, which means A over H. Maya, which side am I labeling 8? Well, A stands for what?
Oh, wait.
Yeah. Perfect. And what about the 10? AB. Perfect. Sebastian, this is a triple. Do you know what that last side is? Perfect. And that's it. We labeled the triangle. So number 11, I took from my Geometry A class, from their notes. And I think we can crush it here. I think we could figure it out. So here we have find the sine of angle C. So this is a trick question on a lot of parts. First part, I cannot use sine, cosine, or tangent unless there's what? Cannot use sine, cosine, or tangent unless there's what? A right angle. Can we just create our own right angle? No, I can't just say, oh, angle A is going to be the right angle. We can't do that. So what we're going to do is what we've done in the past. We draw down that perpendicular. Do you guys remember when we've done that before? And now when I draw down that perpendicular, I end up splitting this 10 into 5 and 5. So now I create two right triangles. And not only do I have two right triangles, I have a nice triple here. What's that triple? 5, 12, 13. So now that I have a right triangle, now I can use it. And it says find the sine of angle C. Since they said angle C, it's all based on angle C. So I'm only using this yellow triangle. I don't care about the other triangle. So this is a 12, this is a 13, this is a 5, this is a C, this is an A. Let's call this point P down here, just to give it another letter. And now everything's in reference to angle C. So now it's saying find the sine of angle C. So what am I going to think of again? SOHCAHTOA. So if I'm finding the sine of angle C, Leilani, what's that going to be? You got it. It's going to be opposite over hypotenuse, which is 12 over 13. So the trick here was we cannot do trigonometry unless we have a right triangle. So we had to make a right triangle there. All right. You know what? I think we can skip these quadrilaterals for today. Maybe we'll pick them up next class. Okay. Let's stop for today.